That will start the CBI webinar, where we'll be discussing energy storage systems related to future European sustainability needs. I would like to highlight that today's webinar will be recorded. If you have any questions, please either submit them to myself or the speakers using the chat functionality, or feel free to ask the questions directly and come on screen. This webinar is part of the European Sustainable Energy Week. And today's agenda that you can see here will be discussing the vital role that batteries will play in incorporating renewable energy into the European energy mix, and also highlight the role that batteries will play in terms of efficient energy use. I think it's clear that demand for batteries will increase substantially in the future. The batteries will really be needed in order to deliver on sustainability goals and also electrification and decarbonisation goals. And that growth, that demand will be so large that we need all types of battery technology. It's important that we have a suite of battery technologies available in Europe. So today we'll be talking about advanced lead batteries, using them in systems both alone and in combination with other technologies such as lithium-ion in hybrid solutions. Now, some of you here may not be aware of lead batteries, and if you are, perhaps you think about them as the battery that starts your car. But the lead battery of today is very different than the lead battery of 10 or 20 years ago, and there have been significant performance enhancements that we'll hear about today, driven by industry-backed research and innovation. Lead batteries have been around for a long time, in some cases over 100 years, and used in a wide variety of applications. And this means the chemistry of lead batteries is very well understood, which means they're very reliable, they're very robust, and they've shown to have very high safety. And the other benefit that we'll probably hear about today is recycling. Lead batteries are collected and recycled in a closed loop in Europe and North America. Almost 100% are collected and recycled at end of use. And that obviously has significant benefits in terms of lower environmental footprint and also increasing the sustainability of lead batteries. So, as I said, the agenda that you can see before us, we'll hear from CBI representatives and also from members within CBI, Exide, and also hear from GSU Asset about projects that are currently underway using lead batteries. But our first speaker today, I'm pleased to introduce, is Dr. Carl Telford, who'll be talking about advanced lead batteries and the role that they can have in delivering in Europe's sustainability goals. So over to you, Carl.
Thank you very much, Alistair. I appreciate your introduction. Can you all see my screen?
We can, Carl.
That's wonderful. So today I'm going to be talking about the ways in which advanced lead batteries and supporting technologies can support Europe's sustainable energy future. So just building on some of the introduction that Alistair has provided to us all there, a really, really important nugget in what Alistair said is that sustainable economies need batteries and lots of batteries. If we're going to solve the problems of climate change and pollution and enable a move from a linear to a circular economy, then we're going to need appropriate deployment of battery technologies. We're going to need a lot of energy storage. So as it says on this slide, we need batteries and lots of them. So battery energy storage is a pillar in the move toward electrification across many different sectors. We're already seeing soaring demand for batteries. And in many ways, this is a golden age for battery technologies. Thinking about some of the applications, we are talking about large-scale energy storage, small-scale energy storage, and we're talking about stationary applications and also transportation applications. And all of these activities driving innovation, research, and development in batteries across the globe, across all of the sectors I talked about. So being very specific, we have automotive, energy storage, industrial, motive power. Governments across the world, and as this is European Energy Storage Week, in particular the European Union, have set some really, really tough targets. I'll show you some in a while. And we will need a number of enabling technologies, a large number of enabling technologies and solutions to make progress on those targets. Now, CBI, the Consortium for Battery Innovation, is very much supporting this activity. We are a global organisation, and as you can see from this slide in front of you, we have well over 100 members spanning the entire battery value chain, from battery manufacturers to end users, industry suppliers, research and testing institutes, and primary material suppliers that are involved with the CBI community. And CBI itself has been in existence in one form or another for three decades or so. And we have, in that time, driven innovation and advanced projects in battery technology. What I'm going to be talking to you about in the over the next 15 minutes or so, the three things that you can see here on the screen. So I'm going to be introducing you to the CBI Roadmap. Now, this roadmap sets out our innovation landscape for lead batteries, the things that we have charged ourselves with achieving going forward over the next 10 years and beyond 10 years. I'm going to talk to you a little bit about that innovation roadmap. Then, because this is European energies, this is a European event this week. We want to think about how what we are doing as a global partnership and membership overlaps with the goals that are being set by governments in Europe, particularly the European Union. So we're going to have a little look at some of those key targets, things like the European, the Green Deal, and look at how they overlap with lead batteries. I'm also going to emphasize how we need immediate action. And then I'm going to talk a little bit about some of the project initiatives that are ongoing. So that's item C here, the funding, research and investment landscape, and how our industry, lead batteries and supporting technologies fits into that. So kind of closing the loop on this presentation. So the first thing I want to talk about is our roadmap. 2 weeks ago, we launched our latest technical research and innovation roadmap. I strongly advise those who have not done so that are on this call to go onto the Consortium for Battery Innovation.org website, where you can download a copy of our roadmap. Members get access to a more detailed version of this, but for anyone else, there is an access to an overview version of the roadmap. It's still fairly comprehensive, so I recommend you go and check it out. But this roadmap, it details our research and innovation pathways for next generation advanced lead batteries. And it's building on previous documents that we have put out, previous roadmaps, but we've added a lot of content this year. We have some significant KPIs in this roadmap. I'll tell you a little bit about those KPIs here. So we've set out in this roadmap a number of specific goals and KPIs that will enable us to grasp opportunities in key markets. These include automotive market, energy storage systems market, industrial applications, motive power, and other applications. I'll just talk to you a little bit about each of these. Excuse me. I'm sorry, our phone was going off. I do apologize. So our goals include for automotive include. I'm sorry, someone is speaking. Can you please make sure you're all on mute? Thank you. So in terms of automotive, we have targets and KPIs around stop-start micro hybrid batteries. So we want to ensure that recent improvements in dynamic charge acceptance are maintained while improving high temperature performance and ensuring we don't have trade-offs in other areas, for example, cold cranking. We also have a huge focus on low voltage EV batteries. So these are 12-volt batteries that are used to enable auxiliary functions in highly electrified vehicles, XEVs. With these batteries, we want to improve DCA and charge acceptance while increasing charging efficiency and lifetime. So there's quite a lot in our roadmap around automotive applications. In terms of energy storage systems, so these can be large or mid-scale energy storage for supporting, for example, supporting microgrids or grid applications. We have targets and KPIs around improving cycle life, calendar life, and round trip efficiency, while also reducing acquisition and operating costs. For industrial applications, we want to improve cycle and calendar life while reducing battery costs. These industrial applications include telecoms applications and also uninterrupted power system applications. Motive power, we have KPIs around lowering total cost of ownership. So motive power are things like forklift trucks. And we want to increase cycle time, lower recharge time, and focus on producing maintenance-free batteries. That's just an outline of some of the content and KPIs that are in our roadmap. I strongly suggest you go online to our website and download that roadmap. So that's some of the research that we are driving within CBI. I'd now like to think a bit more about the overlap between that roadmap and key European goals. So I've been conducting quite a lot of research in the last few months since I've been at CBI. And as part of this, we have been looking at what the high-level goals of the European Union are. What are their major targets going forward? What you see on the screen here maps out some of the initiatives we've got, particularly around the European Green Deal. And this is out to 2030, and indeed beyond 2040 and out to 2050. For example, climate action. The European Union is targeting a reduction of GHGs by 55% versus 1990 by 2030, and with the ultimate aim of being net zero out 2050. You can see that there are 8 of these targets highlighted on this slide. The second one down, I'm not going to go through all of them. The second one down is particularly important. The European Union wants to transition from the current linear economy towards a circular economy. So that means that everything is done in a closed loop. Manufacturing, supply, use, feeding back into manufacturing, supply, use, closed loop. We have targets in place to achieve this transition, and they're very ambitious by 2050. There are obviously intermediate goals, a reduction in municipal waste, and we have things around the 2030 Sustainable Development Goals that point to a circular economy as well. Below that on this slide, you'll see a number of other ambitions across Europe: eliminating pollution, renovating buildings, enabling clean energy, sustainable mobility, and a sustainable industrial framework. These things you'll see on this page need a number of enabling technologies to work. If we think about energy storage, what we need to enable that includes some of the things that I have in red at the bottom of this page. So we have things like mass market energy storage, safe energy storage, circular energy storage. The critical thing here, I think, is timeliness. We need to act immediately if we're able to achieve these goals that we see at the top. The European Union has set very ambitious 2030 targets for decarbonisation and circularity. And realistically speaking, these targets can only be achieved in this short timescale, 8 years or so, by developing and deploying multiple technologies. One of the things that we have as an advantage in our industry, lead batteries, is that they could be a rapid enabler for change. We already have the technology, it's just a case of deploying it. They can make a real difference in the short term, which for climate change could be a big deal. The sooner we act, the better things are. And it's the same with circularity as well. As Alex still was saying, we have a circular product. So we can already see there are some clear synergies between the EU targets and lead battery research and investment. I've highlighted on this slide here how if we look upwards from what we're doing in our community, R&I to improve lead batteries, there is a clear feed into meeting those targets. So at the bottom right-hand part of this slide, we can see that our activities in telecoms backup, vehicle charging, hybrid and electric vehicles feed in to the goals that we have at the top of the page. So for instance, in terms of climate action, all of the top 4 applications that we are developing and are described in our roadmap have an impact on that climate action goal, a positive impact. And again, those technologies are available and deployable. What I'd like to give you now is an example of a project that has been completed over the last few years, that's been conducted by one of CBI's network. So this project talks about, this slide talks about a project being developed by Sunlight Systems, who've developed an energy infrastructure in Sierra Leone. It's called the Rural Renewable Energy Project. And you can see we have a number of partners involved in this. The first phase of this project installed solar power mini grids at over 50 community health centres in Sierra Leone. The second phase provides electricity to houses, schools, businesses in 50 rural villages. So what we have in this is a combination of sunlight cells, solar cells, connected to a hybrid system of 90 mini grids. And this system, using our battery technologies, has enabled significant sustainable electrification of those 50 rural communities. And that's around over 350,000 people that have been impacted for this. The batteries that are used in this are well suited to renewable energy. They have long, reliable power cycles. And again, I'll come back to circularity. They are also fully recyclable at end of life. And what I've done at the bottom there is I've cross-cut the aims and outcomes of this project with those 8 key goals of the European Union. And you can see that this is enabling, I'll pick a couple of these. It's enabling deployment of renewable energy, which is reducing GHG emissions, and it's using circular batteries, so recyclable batteries. So it's an enabler of circularity. It's stopping people using generators and other technologies, therefore we're reducing pollution. And it's renovating the communities that we see. I could go through all of them, but I think you get the idea that from this project as a microcosm, it shows how battery technologies in general, including lead batteries, can be used to make a real difference in the energy landscape, and therefore on the climate. I'm now going to very quickly talk about some of the work that we've been doing in terms of research and innovation and the funding landscape that we have in Europe, because we're going to need to conduct a bunch of projects and accelerate the adoption of energy storage technologies. So what I've been focusing on in the last couple of months is reviewing the European funding and project landscape and seeing where the opportunities are for battery technologies. It's a really complicated landscape. There are well over 30 funding instruments. So there are over 10 at European level and tens at a national level. I'm not going to go into it in too much detail today, but you obviously have things like Horizon Europe and the EU Innovation Fund, but then you have national programs as well. So you'll have PIA4 in France, for instance. And these instruments, as they are called, according to industry roadmaps, are funding research and innovation. So I've been looking at these. And what we've been looking at is where can we make a real difference as a community? Where can our energy storage organisation and our partners make a real difference? And we determined 7 opportunity areas where lead batteries, we feel, can make a real difference going forward. And we are now starting to develop project proposals around, and I've highlighted 3 areas here. There are more areas than that, but around energy storage systems, particularly around microgrids, low voltage EV batteries, so 12-volt batteries for highly electrified vehicles that support critical functions. And also batteries to enable EV charging, so buffer batteries for EV charging points. I will just say on this that we are looking for industry and academic partners. So if anyone on the call is interested in projects around those 3 areas, then please shout out to me, get in touch with me, and we can see if we're putting consortium together. Let's see where we can work together. I want to finish by summarizing what I've just talked about. In the blue, we have CBI's roadmap, where CBI is going. We have fundamentals and targets, KPIs around a number of things in 12-volt automotive, in energy storage systems, in industrial applications such as telecoms and UPS, and also motive power. We have innovation areas above that. So we're looking to develop circular batteries for all of these applications. We're looking to develop hybrid and dual battery systems. So in energy storage systems, and we'll come on to that in the rest of this seminar, this event this afternoon, harnessing the functions and the strengths and capabilities of multiple battery technologies, where you've got lead batteries, lithium batteries working together in harmony, and a bunch of other innovation areas that we're looking at as a community. The overlap between those things and the European Union goals is very, very strong. And to complement that, there are 2 other things on this chart here. We're thinking beyond our immediate KPIs. Why is it we cannot enable complete recycled batteries? We're certainly looking towards maximizing recycled content. And then net zero energy storage is another thing that we're very, very interested in as well. So that's topics like that could well be the subject of future R&I. And we want to conduct collaborative programs and research and innovation that complements those European Union goals going forward. Thank you very much for your time this afternoon. I'm now going to stop sharing and hand over to Joanna.
Well, thank you very much, Carl. I think it's a very important presentation highlighting the role that lead batteries can play, and also the need to deploy batteries now, and the fact that lead batteries can meet that requirement right now and at scale. We will have a panel discussion after our coffee break, but if people have any specific questions for Carl now, please send them via the chat function, or feel free to speak directly to Carl. If the
Kyle, microphone.
Hi, Alyssa. You're asking a question, Alyssa?
No.
No. Okay. In which case, I would encourage you to ask questions in the panel discussion. So we'll now move over to Joanna from CBI, who's going to be talking about a number of the CBI renewable projects and the work that CBI has been doing in this field. So over to you, Joanna.
Good afternoon, everyone. Let me just quickly share my screen. I think you can all see it now. Okay, so across the globe, advanced lead batteries are used to deliver safe, reliable, and sustainable energy storage. As you can see, this is how our interactive map looks like if we look just into Europe. The large-scale frequency regulation projects supporting the Central European energy grid are powered by advanced lead batteries. And our members and the European lead battery industry in general are a critical part of Europe's sustainable energy future. After this coffee break that we're going to have virtually, we will hear from speakers who will be showcasing some examples of advanced lead batteries in action across Europe, showing us how this technology is playing an essential role in delivering clean and reliable energy, such as Exide and their project involving renewable energy, and GS UASA, that is also going to show us the importance of hybrid projects. So for more information, make sure to check out our website at batteryinnovation.org. And please follow us on Twitter at CBI Batteries and on LinkedIn at Consortium for Battery Innovation. Thank you so much for your attention and enjoy our event.
Thank you very much, Joanna. I think that's we have an interactive map, as Joanna said, on our website that highlights projects worldwide using lead batteries. And I think that has been an eye-opener for many people, because when you think about, many people think about battery technology, they think about other technologies, lithium technologies, rather than lead. But in fact, there are many projects worldwide utilizing lead batteries, and many of them utilizing renewable energy. And one thing I would request is that those companies that are online, if you are aware of projects that are not on our interactive map, please do contact us. Let us know, because it's a great way of highlighting the great work of both our membership and the lead battery industry as a whole is currently undertaking in the field of energy storage. What I would suggest now is we'll take a quick 10-minute virtual coffee break, and then we will be back where we'll be hearing from specific speakers on some of these projects that are undergoing, from Holger Fricke from Exide and Peter Stevenson from GS UASA, and it will be chaired by Patrick Clarence from EASE. So we'll have a quick 10-minute break, and we'll come back to hear those presentations and the panel discussion. Thank you very much. Right, let's kick off the second part of our webinar, looking at the future of European sustainability. As I said, this afternoon we'll be changing tack and we'll be hearing about case studies, and it will be moderated by Patrick Clarence, who is Secretary General of EASE, the European Association for Storage of Energy. So with that, I will hand over to Patrick, who will moderate this session. Thank you very much for joining us, Patrick.
Alistair, thank you very much. Thanks to CBI for inviting me. I'm very happy to be here. We're a minute early. Maybe we'll wait a bit to make sure that everyone can join and they're not still running around with a cup of coffee or the virtual cup of coffee, and that we will all be in the session. I mean, it was very clear what you showed in the morning or in the first half of this afternoon, which is the role of the lead-acid batteries and advanced lead-acid batteries. And also, it was very interesting for me to see the different projects which are implemented for the moment, and which shows clearly that there's an interest from the market into to have this technology deployed. So it is very, very nice to have this information shared with the participants. So now, spot on time. I hope everybody is there. We'll start with the second session after the coffee break, and I'm very happy to have with me Holger Fricke from Excite Europe, but also Peter Stevenson from USA. And we will, in this session, look a bit at case studies about what is really done. And after this, we'll have a panel discussion where we can also take up questions which coming from the audience. And if there are no questions from the audience, which happens from time to time, I will make sure that we will go deeper in these topics you presented. So the first speaker of this session will be Holger Fricke, Dr. Holger Fricke, because he holds a PhD in physical chemistry from the Technical University of Kaiserslautern in Germany. He's Director for Basic Research at Excite Europe, and he joined Excite in 2008 as material engineer and developed different technologies. And he used to work as Director for Industrial Product Development EMEA. And now his topic is renewable energy storage for manufacturing, which is quite a big demand. Holger, I will give the floor to you, please, if you can share your screen. And then, oh wait, before I give it to you, sorry, I need to fulfill what I was asked to do, and I'm too much into the next speakers that I forgot completely that I have also something to share with every one of you, and this is the role of storage. So I have to do this introduction. I would like to do this introduction, and yeah, it's a bit, I hope you can see my screen, because it's a bit a topic which is mentioned a lot. We see a lot of activities for specific technologies. They are mainly driven by one technology in the moment, which is lead-acid batteries. And another technology is pushing very strongly also is hydrogen. But we believe that obviously we need these technologies, but they are not enough to solve our climate targets or the energy transition topic. So first of all, EASE. Who is EASE? EASE is a European association of almost 60 companies. We are at least more than 50. We are a whole chain. So we're talking about companies making components, materials, but also developers. We have companies who are utilities, research centers, and we also have distribution system operators and transmission system operators in our membership. So it's a whole chain, which is very good because it reflects the sector, but can be quite challenging if you have a topic like ownership of storage. What will happen, or what do we see for the moment? On the left is today, and we see that there are very small applications. They're pointing their nose, they're starting on weaker grids, on supporting the grid, on valuable renewable integration, but also generally sector integration. I mentioned hydrogen before, but transport is another example. This will increase in 2020s, so this decade. And then in the 2030s, we will see that we will have almost 100% renewable also on larger islands, which will become economic. We believe that we will have a lot of longer-term services also. For the moment, we have very short-term grid services. We need to avoid the curtailment of variable renewables. We see this happening now. A huge gas price increases the electricity price. And if we have the renewables, which we don't curtail on one side, and then use backup power, which is often gas on the other side, then we would avoid to have these spikes in gas prices. So storage is helping to avoid these high prices. But therefore, you need to roll out storage also for bigger shares of energy. And the last part is sector integration. We will not decarbonize if we don't decarbonize the transport, the heating, the cooling, and therefore you will see that via different energy carriers, energy storage will also decarbonize other sectors like transport and heating, cooling. So for the energy storage, this means we need a wide array of energy storage technologies, which also means a wide array of battery technologies to be able to address all the flexibility needs and to be able to achieve this energy transition in a cost-efficient. We see that we have different technologies, different battery technologies also, which have a different performance on power, energy, the density, also the capex and the cycling and all the rest. So all these parts are important if you choose the right technology for the right application. We see that we have some applications which need a lot of cycles, we need other applications, we need more energy content. And we see that today already, and since a long time, since decades, that acid technology is used in a lot of these applications. And this means, as a consequence, and I will try to finish with these last slides, that we need a level playing field between different technologies. No one can pick the technology winner. We read more and more about new technologies, about new battery technologies also, or a hybridization of technologies, which marries the best of two worlds. And these needs to be rolled out and be available to achieve the flexibility and energy storage needs for 2030. Therefore, a lot of technologies exist, but there can be all these technologies need to work together to increase the potential behind them. And this is done on European level. There are a lot of initiatives to demonstrate this. And I wanted to give a short overview. On European level, on the left-hand side, you see the European Battery Alliance, which is pushing for a competitive manufacturing value chain and also building up a lot of gigafactories or battery factories in Europe. We see Batteries Europe, which is a research and innovation ETIP, the European Technology and Innovation Platform. And this ETIP is uniting stakeholders in order to identify the priorities for research, applied research, and mobilize also the necessary resources. While complementary to this, it's Battery 2030, which is looking now in the variation of Battery 2030 Plus, it's a follow-up of the first call, into a longer-term research, but also obviously giving recommendation what needs to be done now. And this is complemented by the EPCIs, IPCAs, IPCI. We can have different ways of saying this. It's important projects of common European interest. And these projects unite stakeholders in two classes. There are two IPCEIs, which bring all the chains together to implement batteries and the battery production in Europe. And an IPCEI is basically a vehicle which allows for state aid to be given to the members. So that's about my introduction. And now, since I introduced Holger already, I will give him the floor directly, and he should be able to share his screen and start his presentation.
So thank you very much, Patrick, for the introduction. I hope you can see my screen now. Okay, perfect. So hello, everybody, and good afternoon. We have already heard a lot about sustainability today, and sustainability is also the nature of the battery industry, and especially for integrated companies that offer product and end-of-life service. CBI Technologies is one of the leading providers of advanced energy storage solutions for automotive and industrial markets and has production and recycling sites all over Europe. Exide is not only committed to protecting the environment and ensuring health and safety for its employees and the people of the communities we operate in, but it's also committed to reduce energy consumption and optimize energy efficiency. For sure, the increase of renewable energy will support the decarbonization in Europe and will help to achieve the climate objectives. But it has been already pointed out, we need also a solution for the increased energy storage demand, especially in renewables, as we have fluctuations between energy production and energy consumption. Lead batteries play a vital role in this mission and can provide a path forward towards greener energy and improved energy efficiency. Today, I will show you as one example, photovoltaic energy generation combined with advanced lead battery storage. And so I called my presentation On-Site Solar Installation Meets Lead Battery Storage. The origin of this project lies already back a couple of years and is related to the expansion of one of our production sites in Castanheira in Portugal. Castanheira is located in the Lisbon area and it's producing AGM lead batteries for stationary applications. At that time, a big investment was made to increase the production capacity. And so, of course, also a solution for the higher energy demand was needed. And Exide was looking for opportunities of being more efficient and also of being more greener in terms of energy consumption. And so many different scenarios have been investigated. For sure, one important aspect was also to have really a sustainable solution for the future. In the end, we identified as the best solution the installation of a solar power park combined with advanced lead battery storage, taking also advantage of the fact that we have already the right batteries in our production portfolio. Despite this important fact, other reasons for the selection were, first, of course, the geographical location. Portugal, with over 300 sunny days and more than 8 hours of sun, is an ideal place for photovoltaic energy generation. Secondly, of course, the green transition. With this project, Exide Portugal was able to reduce its carbon footprint significantly, as we will see later today. Of course, third, an energy cost reduction and a long-term energy management security. Last but not least, it was, of course, also very important and a good opportunity for R&D to gather directly data from this battery on a daily basis and analyze it and to see how is the performance of the battery in this application, also to take advantage and take this data to improve the products for further applications. In the beginning of the project, as I said, many different aspects have been analyzed, not only the technical ones, but also the ones related to the selected vendor, as we wanted to build a strong partnership for future business with a long-term duration. Finally, EDP was a selected vendor for this project, and this was a very important step. EDP is one of the leading energy suppliers in Iberia. After this milestone was reached, it took several months, also due to overcome bureaucratic hurdles, let's say, to get all the required licenses from the authorities. In the end, 2 solar parks were installed in Castanheira and the second one in Azambuja. Azambuja is a lead recycling site very close to Castanheira. And as you can see here on the slide, on the images, the solar panels were mainly installed on the ground floor, but also on the roofs of the production buildings, and even, as you can see here, on the parking lots. And of course, a battery room was installed in Castanheira. The installation in Azambuja was already finished in late 2020, and the total system went live in June this year. The key facts are summarized here. So the two installations in Castanera and Azambuja have a combined capacity of 4.5 megawatt peaks and produce enough energy to supply it to 1,500 homes. 11,250 photovoltaic panels and 17 inverters have been installed, and a bank of Exide Sonnenschein Gel batteries that provides a storage capacity of 500 kilowatt hours. Some additional facts to the battery, of course, and also to its use case. The Sonnenschein A600 has been selected for this project because it has already a proven track record since decades in complex large network power applications. It is a 2-volt cell in gel technology, so it is maintenance free. And this type is produced in the Exide plant Bad Lauterberg in Germany. The design is very robust, especially for deployment in tough conditions. It has a tubular plate design, long service life, and is also protected against deep discharge. And of course, it's fully recyclable. Advanced lead battery storage means in this case, not only putting the battery into some application, but it means also combined with a battery management system. The battery management system was designed by Exide and developed as well. And here we could take advantage from the experience of former similar projects where we also developed BMS, for instance, for the 5M BAT project in Aachen. And the battery bank is an integrated part of the entire system and is supporting to power a so-called green social building that is used by the workers. During the day, the solar panels are providing the energy, and during the night, the advanced battery system is supplying the energy to the social building. And of course, the battery itself is charged during the day by the solar power panel. And so the entire energy to provide to this social building is totally green. I would like to summarize here the highlights, the benefits, and also give a little bit of an outlook. We have been able to achieve carbon emission reductions by more than 20% across both sites. And we see also that now the energy management system is improved, not only by the significant cost reduction, but also because we have generated a very transparent and predictable energy supply for the next years to come. And another indication is that this project has been very successful, that the company has decided to roll out further photovoltaic projects in other Exide locations. The first one is already installed in a recycling site in San Esteban, that is in Spain, in north from Madrid. And other projects are work in progress and are going to be rolled out in the next years to come. Of course, it is a fantastic showcase from the R&D point of view to demonstrate this also in the Castanera facilities for customer visits. It is, of course, also a statement of trust in our products and also a value proposition towards the end customers. Finally, Exide gives a viable business for our end customers, especially for energy-intensive industries, that one opportunity to become greener and more efficiency is to rely on photovoltaic combined with advanced large battery storage that can be used for self-consumption and peak shaving. That's all from my side for today. Thank you very much for your attention.
Thank you, Holger. Thank you for your presentation. It was very clear, and it's nice that you managed to point down the added value, the economics, and also the environmental added value. Thank you very much. We will come back to the discussion in a moment. In the meantime, I'm very happy to introduce Peter Stephenson. Peter is Senior Technical Coordinator at USA Batteries Europe, and he studied chemistry in Cambridge and worked in the battery sector since 1980. So probably he's the one of us all here in this webinar who worked the longest on batteries. So you have quite some experience you acquired. He's actually looking into technology coordination for the introduction of new energy storage products into European market based on the development of lithium-ion and advanced lead-acid batteries by USA Corporation in Japan, by GS USA Corporation in Japan. Peter, please, the floor is all yours.
Yep. Okay. So just to share my screen. Can you? Okay. Can you see the presentation? Thank you. Okay. So thank you, Patrick, for that introduction, and good afternoon, everybody. So yes, I'm working with GS USA, so we're based in Japan, but I work in the European branch of the organization. We're based in Wales, hence the Welsh dragon behind me. And we have a manufacturing plant here, which is producing lead acid VRLA batteries, but also lithium ion assemblies. And so GS USA as a whole is one of the leading producers of both lead acid but also lithium ion batteries, which is one of the reasons why we started to think a few years ago about what are the possible synergies that there could be between using lithium and lead together, and particularly for energy storage solutions. And what I'd like to talk about today is some of the results and some of the activities we've been focusing on in Europe about this. So mainly renewable energy is driving the massive expansion in storage of electricity, and it's all about net zero carbon economy. We need to be moving away from unabated fossil fuels. So obviously coal, oil and gas can be mined and then stored indefinitely and then used to produce energy on demand and to match demand. So it's dispatchable generation, whereas most zero carbon sources are not dispatchable. Wind and solar, they're intermittent, so they have to be harvested when they're available. Doesn't matter what the demand is. And even with other nuclear, tidal, geothermal, they're more predictable, but you can't always match them to the fluctuating electricity demands. So they are likely to require some form of storage, and it's all about balancing supply and demand. And this is where new methods are needed for electricity supply and demand balancing. Batteries obviously are one of the leading technologies underpinning this expanding market. If you look at the different needs of the this storage, that it's not just a single activity going on. So there's a whole list here from power quality, which can just be a few milliseconds to minutes. Really, this is where the UPS activity has been long established. And even with non-renewable forms, you need power quality control especially for very sensitive activities such as data centers, critical infrastructure and so forth. Moving forward, frequency response, because the lack of inertia in the system now as you move towards wind and solar causes more variation in frequency. Batteries really, and the big proportion of batteries introduced recently have been driven by frequency response concerns. But then these are other things, peak demand shaving, over periods of time, asset reinforcement deferral, for example. So maybe you, instead of upgrading a substation or a whole transmission grid, if you need to have a lot of you've put a lot of solar in a particular area, rather than increasing your substations, you could store energy locally to smooth out supply and demand across the grid. The thing about these is that they are all working across different operating periods in the time that you need to store them for different periods of time. And this is a key factor in selecting different types of storage. So this could summarize where batteries sit in distributed energy storage locations. And the large amounts of storage which have gone in recently in Europe, the world globally, are often, mainly this has been over 90%, certainly in the UK, has been lithium ion connected directly to the grid. But all of these other places actually already have batteries in them in many cases, particularly data centers, hospitals, a lot of factories. And these are the UPS function, which is mainly lead acid providing this, this storage. But what are the differences between lead and lithium? And coming back to, there are many, but coming back to this time effect, then this graph, I think, speaks very clearly that showing the rate of discharge. So if you want to discharge very quickly, with lead acid, you soon reduce the amount of capacity that the battery can deliver. Whereas for high power lithium, and there are various types of lithium designs, but for very high power lithium, even if you are discharging in a few minutes, you can still be getting nearly all of the capacity, the ampere hours that you've stored into the battery originally. So this gives you, and it really was one of the key drivers to looking at where could lead and lithium work together. I said there are many other strengths of each of these two technologies, but really looking at it as a dual chemistry, they are perhaps not competing technologies, but complementary technologies. So lithium, extremely high cycle life compared with general lead acid, very high rates of discharge are possible as we showed, but also charge. They can accept charge very efficiently. Partial state of charge operation, they will last probably longer if they're never fully charged, whereas that's not the case with lead acid. But lead acid is very economical. It's very simple to control. It's robust. It's abuse tolerant. And it's got abundant raw materials, low energy requirements for processing and recycling of that. And they're very sustainable materials. So these are all extremely useful advantages with lead acid. This has been recognized for a while now. I wouldn't say this was a new idea. It's just picked up, this one going back to USA in 2012. But these were co-located systems where you had lead acid batteries, inverters, power conversion systems, charging and discharging. Others were lithium, some high rate lithium, and they were all coordinated together by this power pyramid software. So really it was a collection of co-located energy storage systems, and that batch energy management system decided when to charge, which battery to charge, which battery to discharge, depending on the requirements. So it was quite a complex system of control was needed. And more recently, this is an interesting European example of a large-scale wind farm associated storage system using lithium ion, again as 1 megawatt, half megawatt hour, so fast charging and discharging, high power, with a much larger but lower rate lead acid storage battery. And this is based in Poland, starting a year or two back now. What we've been looking at in GSU ASA in Europe is actually a single power conversion system, which is simultaneously connected to lead and lithium together. So the control system between the two is integrated, the power conversion system is integrated, and it works as a single unit, but still gives the advantages in a very cost-effective way. And we've put 2 of these systems into operation now on a larger scale, or at a higher voltage level. We've been looking at 48 volt systems for some time. This is in the UK plant since 2018, 100 kilowatt power conversion system with 275 kilowatt hours of storage. And last year we put into Portsmouth Harbour another 100 kilowatt, 250 kilowatt hour system to integrate with the port's activities and local solar and wind production. So what goes on inside these containers? So this shows a circuit really that we have 3 strings of lithium-ion modules, 144 cells in each one, in each string, and this gives each string is 50 ampere hours, so basically 150 ampere hours of lithium-ion, and this is directly connected in parallel to a 500 to 600 volt bus. And here we have 240 cells of an SLR 500 ampere hour advanced lead acid technology. And these, as you see, are connected directly to the same bus, working through a single 100 kilowatt bidirectional power conversion system. So we have a collection of lithium-ion cabinets and VRLA racks. So when these work, as you start to discharge these things, so this is the voltage, the operating voltage of the system as the battery discharges over a period. This is a long, slow discharge, and over about 12 hours. So the voltage drops away here, and this follows this line. Initially, all of the current is coming from the lithium-ion battery. So this is a state of charge of the lithium-ion battery as it drops away. And this is the current coming from the lithium-ion battery. And there's almost no current coming from the lead-acid battery. As the voltage drops to this level, the currents swap over. So now the lead-acid battery starts to do all of the work in this period, and the lithium is not discharging. So we can get a shared performance from the battery with the lithium leading. And in fact, in this area here, the lithium can be discharging from the lead acid, from the lithium battery, and also recharging into the lead acid battery. And in some cases, this is very useful. This shows what happens if you do a more diverse series of charges and discharges, where the lead acid, lithium-ion battery was fully discharged initially. The lead acid started to discharge it afterwards. And then in this case, as we went into stopped discharging, the lithium started to discharge back into the lead acid. And it becomes fairly complex in terms of the sharing of the currents, but they all stay within a safe operating voltage. There aren't too large currents, so they don't cause any problems in terms of the chemistry of each of the system. And it's particularly as we start to recharge the battery, what it does mean is that we can grab energy very quickly. And where lead acid typically takes a long period of time to fully recharge, once it gets above 90%, we can switch off the power conversion system, and the lithium ion will fully condition the lead acid battery, which at a very efficient format. This just shows you over the period of the operation. So we've been using it pretty frequently, especially over the last year or so. We're doing quite a few tests, so we weren't discharging every day in the first period of time. We stopped in this period here we actually made some upgrades to the power conversion system based on normal development, not a problem. So this was showing the voltages, these are showing the currents as they are being shared. Temperatures were working over a fairly wide range, but...
Peter, you need to conclude slowly.
Okay. So basically we've put this together, and now we are producing a more modular unit where we have lead acid batteries, sorry, the lithium and the inverters in one type of container, and the lead acid batteries sitting in a second container. So basically, summarizing this, we're looking at zero carbon economy, the driving force for this ESS business. Electricity storage is now indispensable. Energy storage giving these multiple benefits and showing that lithium and lead can work in a complementary way. So this is the message we have here. And these dual chemistry packages can have the maximum storage function with a minimum power and control overheads. And thank you for listening.
Thank you for presenting. Thanks very much to both speakers. We will now head to the panel discussion. We have still 15 minutes for a panel discussion roughly. And in there we have Carl. So Carl, welcome back. We have Holger, also to you, welcome back. And then we have Peter, obviously, who stays online. You can use the chat function if you want to share with us, or if you have a message you want a question you want to ask on this topic, please feel free. We have 3 experts who can help you. Maybe I will start first about this marriage of different technologies. And I will take, maybe Peter, you made the most technical analysis to share the most technical data out of this. Why would you not put a lithium-ion battery without lead-acid battery? What is the main reason you would say, this is the reason why you shouldn't put it alone?
It's really to give flexibility, so that if you have a clear single application and you're never going to use it for anything else, then you could choose lithium or you could choose lead. But a lot on the list I showed of several benefits of energy storage and providing many functions to really commercially get a good commercial payback. It's very useful to stack different functions of energy storage. So frequency response, power conversion, and then maybe peak shaving, and they require different storage times. So by putting different technologies together, you can then harvest several or provide several services from the same battery and then generate more revenue in that way.
Great, very clear. Carl, can I ask you a question? You were very clear in the introduction. You explained the added value of lead-acid batteries also. We now heard that it's very good, also very complementary, not only a standalone, but very complementary also to other battery technologies. We see that the recycling of lithium-ion batteries for the moment is starting. But you mentioned that for lead-acid, this is something which is way normal. Could you elaborate a bit more on this, the state of the art of lead-acid batteries, and how you see that maybe some of your members can achieve the same with the lithium-ion? Is there any point you could share with us?
Yeah, I think that's a very, very important point that you raised, Patrick. I just want to overlap with the previous question to start with as well. If we think about what Peter was describing about the marriage of the 2 technologies is quite important. Lead batteries, advanced lead-acid batteries, have the process is not only for recycling, but also for collection, are very, very mature and have been in place for a long time. So that in Europe and the United States, well over 90% of batteries are collected. They are broken down, recycled, and fed into manufacturing again. So we have that. We've been doing this for a long time, and it's a system rather than just. It's not just that the technology for recycling is established. It's that the whole the business model, the collection, the logistics is also well established. And I think there are so many components of that, so many things that the lead battery industry is doing correctly. If we have rates over 90%, well on the way to being fully circular, closed loop effectively, we're doing something very, very right. And there's 2 things here. If we are developing new battery technologies, whether they're lithium, whether they are existing lithium batteries, solid state batteries, different types of chemistries going forward, then learning and studying how the lead battery industry has achieved what it has, and replicating that success is going to be very, very important going forward. And if we think about the system that Peter has described, which the presence of lead batteries not only provides a technical advantage, but it provides a circularity advantage. The circularity of the systems that GS UASA has been developing and deploying in the application shown is going to be impressive, because you've got if you've got the two containers with two batteries in, one of the containers, you have a 90% plus, you have a closed loop energy storage system. So it's going to be very, very important if we transition to 2030 and beyond. We want to ensure that all these battery technologies are not only working together when they're in operation, but we have this closed loop mindset within the industry as well. I hope that was clear.
Yeah, it was. There was a question from David about, give an example of advanced battery that you say is in service so that it can be looked up. So which location is there an advanced battery in service for the? I mean, the ones you put together, Peter, would you consider those as an advanced battery?
Yes, the SLR, sorry, I wasn't sure if that was specifically for me. The SLR 500, these are our most advanced lead acid engine. So this includes valve regulated lead acid. They flat plate, but they contain a lot of the positive active material enhancements which are necessary to reach. We're getting 5,000 cycles from those now, at 70% depth of discharge. So, and they have been in circulation for several years now, and they are the culmination of probably 30 or 40 years of development. So I would say that they are the most advanced energy storage lead acid.
Okay. And coupled on top of this with the lithium ion. Great. Holger, I was very impressed by the fact that you said there's a business case behind it, adding PV and batteries in there, this large scale for Excite, about 20% CO2 reduction, which you mentioned. Why was this not done before?
It's a good question. Why was it done not before? I think that was simply also a matter of fact that the situation was there and the plant was expanded and we needed a solution for it. And of course, you can always question, why have you done not earlier? For me, important is more to mention that we have started now. And it will continue, as we have seen that's a viable business case. And I think it's not only for us, it's also for industries outside lead acid, for each energy intensive industry. And that's the main point to highlight.
Great.
I think one comment also to it, it has been mentioned before also, I think it's always important to have a look on the entire picture. This means looking really from cradle to grave. And here we see that also in these kind of hybrid application, it is possible really to take benefit out of the strengths of individual technologies and combine it and being even more powerful than before.
Thank you very much, Holger. Carl, I see you raised your hand. I have some questions still after this, but please, if you can shortly.
I just want to really quickly back up what Holger said. I think that Excite have been ahead of the curve on some of this. There are currently initiatives within some of the funding instruments in Europe to decarbonize your production facilities and across the value chain. So what Holger and Excite are doing is very much a blueprint for part of that, and it's now being encouraged from a policy level as well. If it's being encouraged on a policy level now, then Excite are doing well to have got in with this project beforehand.
Nice. So I must say we're all very much patting each other on the back how good lead acid is. I will ask, playing a bit of devil's advocate, I will ask a question about what's happening to the other 10%. lead is considered by a lot of players, also the Commission, want to be reduced and therefore considered as something which is dangerous. And what's happening to the other 10%? And the next question I would ask, and this will bring us probably to the end of the session, is then about why would I need to link lithium-ion to lead, and why can I not link it to flow batteries or any other pump hydro or whatever technology? Sorry for asking these questions, but we need to also look a bit from the other side. Please, the floor is any one of you who would like to participate, or maybe Alistair or Joanna, if you want to add, you're more than welcome.
I think one of the, well, we said we've got to start now to do these things, not wait for any time. Lead acid is the thing which is definitely available now. We can get out there and start using it. I'm not saying even if it's
so availability, proven availability, which we say is different than other technologies.
Yes, yeah.
I think the other thing to add here is that because lead is because lead has its because of the problems that you've highlighted, the control over the supply and use of lead, the systems in place, the safety systems that are in place are already very, very well established. And if we have a goal as an industry to be even better than we are at the moment, so going way above 90% can only be a good thing, I think.
I think just to jump in very quickly, I think it also is a scale thing that, you know, demand for batteries and energy storage and all different applications is going to be so substantial that obviously lithium will be a key player, but you need another technology that can meet all the requirements and on a mass market scale. And lead batteries currently have a huge infrastructure in Europe. We're manufactured, we're recycled, and we can meet the current requirements, and we're showing huge performance enhancements. So I think that's what provides a significant opportunity for the lead battery industry, because we can meet the requirements and on a mass market scale.
Very clear. So basically what I see is that somehow other industries can learn from the lead acid battery recycling and the programs around it, and you have this experience you can share with others, and it's really impressive. Impressive to see the high recycling rates you have, so that's really nice. And on the other side, I do agree with you. There's no technology which is 100% without drawbacks. This does not exist. You always have some drawbacks which need to be addressed and minimized. But if you look at the discussion which are around lithium-ion batteries, about the sourcing of raw materials, about how it is done and so on, it is something which is also putting up a lot of questions and prompting more and more players to look into these details. So I think it's a very clear message that you contribute with lead acid batteries to the decarbonization of the society, that you have a product which can increase the efficiency of other technologies, or vice versa, that other technologies put together with your technologies can achieve even more than before. We saw that it is also a business case behind it. It's cost efficient, and it's supported more and more, which is why the rollout of these technologies is starting now to get bigger, because it was already in a more research and implementation in laboratories, but now it is really rolling out and hitting the big market. So we see this change, and we also heard, I think, from Peter about the fact that these advanced lead acid batteries are really hitting the road now. So they are more efficient, they have other plates, they have other compositions. So it was also very interesting to listen to this. So we come to a new era for the lead acid batteries inside an ecosystem of other storage technologies, and pushing for decarbonization and circularity of our economy. So that's very nice. Before we want to conclude, I would like to give the floor to all of the speakers for a last comment, and ask, please, maybe should we start with Carl, you, and then we will move forwards to Alistair, Peter, and Holger for a last comment. Please, Carl.
Yeah, I'll just build on, I couldn't say it much better than you have, Patrick, but the one thing I will add is we need to act now. We need rapidly to deploy energy storage and lead acid batteries in combination with some other technologies, some of the wonderful battery management systems that Holger's been talking about, some of the items that Peter's been highlighting with lithium, we can crack some of this problem very, very rapidly.
Thank you. Alistair, would you like to add something now?
Well, I'll close the session in a minute, but I think one thing I would highlight is that those of you, we often speak to people within the industry, the lead battery industry, and those people know about lead batteries. But for those of you who are new to the industry, new learning about lead batteries, when you think about battery technologies, don't automatically think about lithium ion. There are a lot of other technologies that provide great opportunities that we've heard about today. And obviously being biased, I think lead batteries are an excellent option in these markets.
Thank you, Alistair. Peter, a last idea you want to give to the participants?
Yeah, we shouldn't just think of all these lots of energy storage technologies. Don't always think of them as being competitors and there's only one which is going to wipe the board. We need a lot of them anyway. I'm not sure we'll always have all of them, but we shouldn't think one is going to sweep the board. We need a diversity of energy storage, and we've got to show people how to work together with them to make the right choices.
Thank you, Peter. And Holger, please, the floor is yours.
Yeah, I can in principle only echo what my colleague said already. We need to highlight that we really need all battery technologies to achieve the Green Deal. And we have seen just by today that there are very interesting and useful applications also for lead acid battery as a hybrid system or maybe even a standalone. And this is something we should really emphasize.
Great, Holger. Thank you very much. With this, I give back to Alistair for the end of this session.
Thank you very much, Patrick. Thank you very much for moderating the session. I would like to thank our speakers, Carl, Peter, Holger, and Joanna for their input today. I'd like to thank all the people for attending. I know we had people attending from all over the world, not just Europe. We had the United States, we had Japan, we had Australia on the line today. So thank you very much for your time. I'll also do a pitch for Patrick that if you're not attending his conference later on this month, I would very much encourage you to attend it. It's a very useful conference focusing on issues affecting energy storage.
You can go on the EASE website for the Energy Storage Conference, which will be also a physical conference on the 19th and 20th, and then the 20th afternoon and 21 will be a virtual one. And you can meet and greet people again and network.
Yeah, and
with a COVID safety pass, we would require this.
And CBI staff will be there too, so I would encourage you to be in Brussels then. And finally, Carl mentioned it, but if you would like any more information on the work CBI is doing, please visit our website, batteryinnovation.org. So with that, thank you very much for all attending. We will now close the webinar. Thank you.
Thank you. Bye.
Thank you very much.
Thank you, everyone.
Goodbye.
Bye-bye.